Hi, hello. This class for 12 AB for math elective. So now we gonna learn the new lesson, the applications of integration. But since everyone know, how to say, everyone learn integration as the reverse of differentiation and the indefinite and definite integrals of some basic functions. Everyone had learned this and know how to integrate, correct? And you guys learn substitution also, the integration by substitution. But now we're gonna learn about the applications. Okay, most of we talk about the application of the integration. We will find the area under curve. And why we have to learn this integration, because we want to find the irregular area, like an area under curve like this, right? If you want to find the whole piece of area under here, under curve here, how we can find out? It's really hard, right? Because it's not in the form of like a rectangle or circle or like a geometry you learn from primary level. So this is irregular shape. So we're gonna use the integration to help to find the area of the under curve. For example, like this one, the yellow here. If you want to find that this area of the yellow area here, so for integration we're gonna do by like this one. Come back to the big picture here. We're gonna chop at like a rectangle. I mean, yeah, rectangular. Like for this one, right? We're gonna draw this one like here. Draw up, become like a one rectangle here. From here, draw one rectangle. Okay, that's the one. This one piece of rectangle we can find area, right? But from here, if we from this point P, we draw one line. So from this under curve, this area, this piece, actually gonna be equal to this piece on the top, right? So then we want to find an area under curve here. So how we gonna do? So in general, we're gonna chop like a one small piece of rectangle, one at a time like this. So let now chop smaller and smaller like this. Go on, right? And piece by piece and add it up to be the area under curve of this function y equal to x squared. But anyway, we will show only one piece of rectangle here, and then we're gonna prove the formula of this integration, which we want to find the area of this one, right? So this one we can prove the formula of this one. So now observe this one. If I chop this one become one small piece of rectangle, and the area under curve gonna be this piece. Maybe I draw a color down here. So gonna be this area, the whole thing here. Okay. So this give this one as a delta A. And just another black color. This become delta area. Delta means the small change of area, right? And then this point, if when when you draw this line here, this is gonna be Q, and assign this one as a R. So PQSR. Okay. And this function is a y equal to x squared. Then now we want to find the area under curve here. Okay. Now, and we're gonna prove the formula at the same time. So from at the 0 point up to here is a x, and from here to here is a x plus delta. Like a delta x, we're gonna use a limit function that we learned before to prove, to help us to prove. That means from this point to this point, this one will equal to This one is what? Is a delta x, correct? This one's a delta x from here to here. And then from this point L to P is a y, value of y. Okay, PL is a y. So MQ is also y because the rectangle. So from Q to S is, we can say y plus delta y, correct? So this is the whole thing from MS or SM here is y plus delta y. Okay, when x, remember the definition limit, when the x move to a little bit more like a delta x, from x here, right, you can have y, like this one, this is a y. But when x move to delta x at this point, then we will change at the same time. This one gonna be y plus delta y here. Okay, this is the definition of limit. Anyone still remember or not? After this one, we try to form this one, see, the area, see, like down here, the area of PQML is smaller than the delta area, smaller than this yellow area here. So we name it as the delta A. Okay, the yellow area here. And then this, the yellow color area here, the delta A here is gonna be, is also less than what? Less than area of RSML, less than the area of RSML. Okay. Then area of PQR. This one is true without proof, correct? Because this one, PQML, less than the area of delta A with a yellow area here. And the delta A less than the area of RSML. Okay, this one is true without proof. Then the area of PQML, we can have what? The formula of rectangle area, right? So become PL times LM. So this one PL times LM. This is less than delta A, and this one less than. So area of RSML equal to what? SM times ML or LM, okay? So that SM times LM. Okay, this is the width times length, right? Or length times width. So after this one, can see PL times LM. PL is a Y, right? So you write that as a Y. Time LM is a delta X. So you write as delta X. Less than delta A. Okay, and this one, SM is Y plus delta Y. So just replace it. Y plus delta Y. Time LM. LM is delta X. So delta X. Okay. From this one, we can divide every term with a delta X. Divide every term with a delta X. So this one become Y delta X divided by delta X less than delta A divided by delta X. And this one become Y plus delta Y times delta X divided by delta X. So this one cut, right? Cut, so you left Y less than delta A over delta X less than this one cut, so we have Y plus delta Y. Okay, so from this one, if you take limit, right, limit Y when delta X equal to 0 and limit of delta A over delta X when delta X equal to 0 and this one at the same time. So in this case, just can say if we let the delta X equal to 0, then delta Y we approach to 0 also, correct? After this one, we can say delta A over delta X we approach to Y. Then if you take limit this one, right, but we know if we take limit delta A over delta X when delta X approach to 0, this one equal to what? D of area over dx. This and at the same time, this one equal to Y. This one is we learned before, correct, in chapter 15, 16. Remember this one? This one. If you forgot, go back to see your handout. See chapter 15 and 16, the one proof, and also come from the limit we learned. So any delta x or delta any object over delta x, right? Like right now, delta A over delta x. When you take limit, this one equal to you differentiate above the area over delta over dx equal to y. If you talk function, that's a y is a function. If you talk area, then this one differentiate area over x. Always respect to time. Remember in chapter 16. So in this case, so in this one, from this proof and definition from this case, we can say at the same time we can say this one by y equal to x squared. We can say this one dA over dx equal to x squared also, because this one equal to y, right? dA over dx equal to y. Then at the same time, this one equal to x squared because y equal to x squared. In this, then we form dA over dx equal to y. This one we can, for this one, right? We can, for this one, we can imply that like a of b minus a of a will equal to integrate of y dx. Okay, from where? From a to b. So we always get a to b, get destination minus original point. So we get area of b minus area a. And because y equal to x squared, so in this case, from here, right, the same idea. We can apply that a of b minus a of a equal to integration of x squared dx from a to b. Okay, so this from this case we can conclusion the formula, say the area under the curve. Okay, so we can conclusion the formula here. So maybe I draw, I lay down here maybe. Okay, I can lay down as say the area under the curve y, right? The area under the curve, area under the curve y equal to f of x, right? From say the area the area the area under curve. Maybe I change. Let this one off. Oh. It's okay, right? Okay, so I just lay down here. It's already erased. So area under the curve, area under the curve y equal to f of x from x, like right now, this one, we come back to this one, right? So from x equal to a, okay, to x equal to b, we can get what? Can get, say, area a equal integrate of y dx from a to b, or you can say a equal to integrate of f of x dx from a to b. Okay, this is where f of x must be what? Greater than or equal to 0. For x have to be less than or equal to b or greater than or equal to a. So this is a formula. Okay, this is a formula how to integrate. So this part already is okay. Okay, now now everyone get try to take a look this one more time. This is a proof of the application of integration. How we get the formula? This is a formula, right? Okay. So now next one we see some example how to calculate for the area under curve in each pattern, in each shape, different shapes. Okay, now next one. So here, say if the diagram show part of the curve y equal to 4 over x squared, find question A, the area of region A. This is region A right here. A right here, okay? And this one's a B. So just find the area orange color, orange part and the blue part here. Okay, so we can question A, do question A how to do. See from where to where, from 1 to 2, and this function. Okay, so in this part we can find the area under curve A. Okay, the region A, just say area A equal to, now this one is already, so integrate, it's a diff already, so integrate of what? 4 over x squared from where to where, and now we find A from 1 to 2 dx. Okay, so this one we can convert to be 4x negative 2 dx, right? Like you learn it how to integrate, how to do the integration, and become 4 integrate, right? Become 4x minus 2 plus 1, right? This one, and then over minus 2 plus 1 become negative 1 here. But now no more plus c, okay? But because right now we know the area from where to where, so from 1 to 2. So you can write down there, and then you replace x, right? So you can simplify this one, become 4x negative 1, this one, right? So this one means simplify become minus 4 over x. Minus 4 over x. So then replace 1 to 2. So become minus 4 over 2 minus 4, right? Over 1. Like this, and simplify become negative 2 plus 4. so equal to 2 square unit. Okay, or you can say unit power 2. Okay, so equal to 2. So the area A equal to this one. So when for the area B, do the same way, but from where to where? From 2 to 3. So question B. Okay. Question B, you integrate, you will get the same. Okay, so area B gonna be from where to where? From 2 to 3, but still the same y, right? Same function, like this one. Okay, so you just do the same way, the same step what you're doing here, but from 2 to 3. So I leave this one for that you do by yourself. Okay, so we have many more questions to go, so I skip this one because they're similar idea. So we go the next one. Example. Next example is, say if they give you this diagram, and then this one y is a function of y equal to sine x. Okay, then they want you find the shaded area. This means purple color area here under this curve of the sine function. So how to, so we can get integrate of what? Area y of y mean, that means integrate of sine x dx. From where to where? From 0 to pi. Okay, so now you integrate sine become minus cosine, correct? So we have minus cosine x, negative cosine x, from where to where? From 0 to pi. From 0 to pi. Then you just replace again the same idea to do, like this one, and minus cosine 0, minus here. Okay, and then you just replace cosine pi. Cosine pi is what? Cosine pi at is the 1, right? Cosine pi, or this side, so become negative 1. Okay, so you have negative 1, and then minus, this minus become plus, right? And cosine 0 is 1. So this one become 2. So square unit. Okay, so become square unit. So that's a final answer for this example. Okay, this one still not too hard. We go next one. Next example. The diagram shows the region bounded by the curve y equal to e power x. This x, okay. This is a x. This one's a x. This one x, okay. And the axis and the line x equal to a. This I mean like this way. This is a, okay. Where a greater than 0. Find in the term of a the area of the regions. B, given that the area of the region is 3.5 square unit. Okay, calculate 2 decimal point, 2 decimal place, that means 2 decimal point, and then find the value of A. And they give this graph, this diagram. So that means find this area, the yellow color here. Now we have this area from where to, from 0 to A, but A is unknown. Then question want us to find. and this curve, this function is y equal to e power x. This is the x. Okay. So how we get the area of this region, right? Okay, now then the area of this region, the area, say I give say area of A, okay, become what integrate of the integrate of y, right? So y equal to e, so e power x and dx from 0 to a. From 0 to a, different color here. So then integrate ex, we have ex and dip the top x become 1, right? So it's the same. So then from where? From 0 to a. Then now not plus c anymore, okay? Because we know the boundary from where to where we want to get. So then after this one gonna be e, use the destination minus original, so a minus e power 0, so become e a minus 1. Okay, so this one becomes square unit. Okay, but after this this is a question A, right? Question A. Now we go B. Do question B. Given the area region, this one equal to 3.5, calculate the two decimal place, the value of A. So this, we know this area equal to 3.5, so you replace area this side become 3.5 equal to E power A minus 1. So this one move become EA plus become 4.5, right? 4.5 then we take long, right? Become A long E equal to long 4.5. Long E is a 1. This one equal to 1. So A equal to long E 4.5. Then you can use calculator. Use the calculator and get the two decimal place. Okay, so I leave this one, let you use calculator. Okay, so we go next example. Okay. Okay, next example. The question says the diagram shows path of the curve y equal to cosine to x minus pi over 6. Find question A, the x coordinate of the point A. That means this one, okay? That means this point where the curve cuts the x-axis. Cut the x-axis. This is the x-axis. So this point from the question say this one is the x, and x is equal to A there, right? And y, this point y is a 0. So this point x, coordinate x are unknown, we have to find. And go next B, find the area of the shaded region. So how about we start? Oh, B, find the area of shaded regions. That means find this, the yellow shaded here, the yellow color area. Okay, so this question B we have to find. Now we start for question A first. To find question A, the x coordinate of the point A. When they say the curve, this curve, right? They say this function or this curve y equal to cosine to x minus pi over 6. This function or this curve cut at the x-axis. So then we know y equal to 0. So we replace from here, from this one. Replace y equal to 0. So we can write that because of y equal to cosine to x minus pi over 6. Okay, then y equal to 0 equal to cosine 2x minus pi over 6. Is equal, okay. So then we can find arc cosine 0 is what? Pi over 2, okay? Equal to 2x minus pi over 6. Then we solve for x. Then 2x equal to pi over 2 plus pi over 6. This is a pi, okay? So LCM 6, so this one 3, 3 become 4, right? 4, 1, 4 become 2, LCM 3, 4 become 4 over 6 pi. That means equal to 2 over pi. 2 over, 3, 2 over 3 pi. Then 1x gonna be, just divide 2 over 3 pi times 1 over 2 pi. Sorry, 1 over 2. So when cut, we left pi over 3. So we get the answer for x coordinate now. The x coordinate here, from here, x equal to pi over 3. That means this point going to be pi over 3 is 0. This one pi over 3. Okay, so now we get this question A, we finish. Now go question B. 5B. The area of the shaded region, then we find the yellow color. Okay, find the yellow color here. Then we have to integrate, right? From where this is 0, from 0 to pi over 3. So because of this one, we have this a differentiate already. This a differentiation. This one like a rate of change, right? So we replace as a. So can say maybe I can assign this one as a area B. I give this one B. Okay. So area B, area of B will be equal to equal to what? Integrate 0 to pi over 3. And write down this one become cosine 2x minus pi over 6. Okay, then we integrate this one, become, integrate cosine, we have sine, right? So we have sine 2x minus pi over 6. And then have to dip inside, right, about inside cosine. So differentiate 2x minus pi over 6. Palm, this is a dip, okay, palm. And then from where to where? 0. From 0 to pi over 3. Then we replace now, simplify from 0 to pi over 3. So this one gonna be, oh, okay, we dip this one first. How about that? Okay. So this one gonna be sine 2x minus pi over 6. And the bottom here, when you differentiate 2x minus pi over 6 is a constant, so become 0. So differentiate 2 pi, 2x, so x 1 minus 1 become x power 0 is a 1, so we left 2 here. Then from 0 to pi over 3. Okay, now we simplify, replace, after this we replace first x with the pi over 3 and next 0. So, and I write down here. This one gonna be, so we can get 1 over 2 out, right? 1 over 2 and the whole thing open bracket. inside here gonna be sine 2, replace x with pi over 3, become 2 over 3 pi. 2 over 3 pi, right? This one gonna be 2 over 3 pi minus pi over 6. And then over 2, get out already. After this gonna be minus sine. This one replace x with 0. Okay, so 2 times 0 becomes 0. Minus pi over 6. Close the bracket. 1 or 2 have to time the whole thing. Okay, now we simplify. Now we can simplify now. Okay. So this one go up here. Okay. So area B equal to now 1 or 2 outside. So then simplify this one sine 2 over 3 pi minus pi over 6 LCM 6. So time 2 become 4. 4 minus 1 become 3, right? So 3 over 6. So become 1 pi over 3. Yes, pi over 3. Pi over 2. Okay, because 3 over 6 become pi over 2. Okay, here this one when you do it, LCM become 2, 4 pi. 4 minus, yes, correct. Become 3 over 6. So left pi over 2. So we're gonna have here become to write down as sine pi over 2. Okay, and then minus this one gonna be sine minus pi over 6. Close the bracket. Then simplify this one gonna be 1 over 2. Sine 90 is what? Sine 90 of over hypotenuse become 1 minus, and then this is a formula, correct? Formula of cosine. This one, you remember the formula sine minus theta come out with equal to minus sine theta, equal to minus sine theta. So this one minus become plus. Okay, this one become plus sine pi over 6. One over 2. And then this one plus sine pi over 6. Sine pi over 6 is 30 degree, right? So sine 30 degree is 1 over 2. So we left this one gonna be 1.5, correct? So become what? 0 become 0.75 square unit. Okay, so this is a final answer of the area B. Okay, that's for this question. We go next. This one say the diagram shows here part of curve y equal to x times x minus 2. Find the area of the shaded region. So find the area here, yellow color here. So maybe I write down as a big A here. So find the area A. This is a yellow color there. This function y equal to x times x minus 2. Then we can say find the area of this one. Area of a, then equal to integrate of what? X times x minus 2 dx. From where? From 0 to 2. But now observe, this area happen under the x-axis. So this all negative side, right? This area, the yellow color here, is happen under the x-axis. So this area should be negative. So from this one, you have to negative the whole thing here. Like the negative side here. Okay. So it should be negative side. Then we can, this one we can simplify, become, delete it down. So this one become x squared minus x squared minus become plus 2x. Okay. And the whole thing dx. Because this happened earlier is under x-axis, so it should be negative side. So you like negative. And now we integrate this one, correct? But this function, area of this function is under x-axis, so it should be negative side. So we integrate next negative x power 2 plus 2x dx. So this one you know how to integrate now, right? So minus x to x, this one become 3 over 3 plus 2x power 2 over 2 from where to, from 0 to 2. And then we come minus x cubed over 3 plus x squared. Okay. Then you know how, just replace 2 first and minus 0. So this one gonna be big bracket here. Minus 2 power 3 become 8 over 3. Plus 2 power 2 become 4. This one. And then minus replace 0 in this one. So become, the whole thing becomes 0, correct? 0 plus 0. So now we have negative 8, 12 over 3 become 4 over 3 square unit. Oh, okay. Square unit. I mean, should be S here. Square unit. So become 4 over 3 square units. Okay, that is this example for the final answer 4 over 3. This one only just say the area under curve here. I mean under x-axis should be negative. Okay, then we go next. Hopefully this may be the last example. Okay, this one. The diagram show that part of the curve. Now, this curve is y equal to y minus 1 plus 9 over x squared. Find the area of each of the two shaded regions A and B. So this one, region A, the blue color, and the purple color, area B. Okay. So we've this similarly now they mix that you see area above x-axis. This one gonna be plus. So this one the bottom should be minus. That's all. So we see if we want to find, maybe just say question A, find the area A, area of A. Just integrate what? Minus 1 plus 9 over x squared and the whole thing here dx from 2 to 3. Okay, from 2 to 3. So now this one you know how to integrate. Become what? Integrate 1. That means x power 0. So you have negative x plus, you can do this one, this one as 9x negative 2, and then plus integrate become 9x minus 1 over negative 1 here. Okay, so this the whole thing from 2 to 3, and then simplify this one gonna be minus x minus 9 over x from 2 to 3. Okay, so I leave this one, let you do, just replace x with 3 first, 3, and then minus, replace one more time for the original point to replace x and 2. Okay, so we go to get the area B. So the similar now, I think I will leave it, let you do it. Okay, for B, find the area B, same as the previous example, because this is below x-axis, so this one gonna be say should be minus here, right? This one should be minus, and then open minus 1 plus 9 over x squared dx. Now from where? 3 to 5. Okay, so that's all you need to do. So this one you just simplify before you integrate better, become plus 1 minus 9 over x squared dx. And then you do the same, do integration, same with the equation A, the same idea, but replace from 3 to 5. Okay, so I leave this one for you that you do by yourself. You try to do it. Now, the answer for this one is a 4 over 5. You see, can you get or not? Okay, square unit. And this one, the answer gonna be 1 over 2. You try, do it by yourself, okay? 1 or 2 square unit. Okay, so I think that's all from now. How to get the area of this kind of function. Find the area under curve. Don't forget, find the area under curve. Okay, and this only one function. Okay, and then I think I will give you assignment for practice these lessons. You check in GC, okay, or should be in GC. Okay, I think that's all for today. If any question, just ask me again in Line group or individual, or ask me in GC. It's okay. Okay, that's all for today. Thank you. Bye bye.